Zombie apocalypse.
Welcome to Bicol University College of Industrial Technology. Busit is one of the colleges in the East Campus. Originally, the East Campus was just referred to as Brasat Campus. Then, Brasat became Busat, and later on, the College of Engineering was added, that for a time it became the campus for Buseng SAT. Just recently, the Department of Architecture became an institute, and so the East Campus now has three Bicol University colleges: the College of Industrial Technology, the College of Engineering, and the Institute of Design and Architecture. Busit is easily recognizable by its landmark, a concrete sculpture of a man holding a mallet, nicknamed Boy Maso. Conspicuously erected in the middle of a crossroads, a few steps from the SIT Arc, Boy Maso stands like a sentry of the SIT campus. Boy Maso is practically as old as some of the buildings of the college. One building, which is older than Boy Maso, is the Electrical Technology Building. Right now, it is almost completed and will soon be ready for occupancy for the electrical technology students. In the building, especially the laboratory rooms, electrical technology students will learn about electrical connections, installations, and the like. They get to practice how to become electricians, and so the laboratory rooms are designed for their hands-on practices. The building will also later house the offices of the various organizations, including the college publication. Meantime, the building is not yet granted occupancy. The Electrical Technology Department is in one of the newest buildings, which I will introduce in a little while. Another old building which has stood and weathered innumerable typhoons is the long single-story building to the right of Boy Maso. You will notice that its rehabilitation is almost at its completion, and soon it will look as good as new and ready for occupancy when this pandemic is over. Half of the building and the end closest to Boy Maso was previously occupied by the Automotive Technology Department. The opposite end, on the other hand, is occupied by the Mechanical Technology Department, so you will see inside some of the equipment that students use in their laboratory, such as the lathe machine, milling machine, and CNC machine, to name a few. As I have mentioned, the Automotive Technology Department used to occupy that old building, but now the department is housed in the ground floor of one of the newest buildings in Busit, the Multi-Tech Building. In one spacious room, automotive laboratory showcases their various equipment used by students in learning about auto machine parts and engines, as well as other similar concepts and applications. Also in the building's ground floor is FabLab Bicol, a technology hub of the region where anyone can make almost anything. In FabLab, you will find various equipment necessary for prototype making, such as a 3D printer, laser cutter, among others. The second floor is currently occupied by the Electrical Technology Department, and the third floor is where the Electronics Department is lodged. In the Electronics Department, there are also laboratory rooms where the students get practical knowledge and acquire skills on the use and application of electronic parts, such as the creation or innovation of new electronic gadgets. To Boy Maso's left, but to the right of the SIT Art, is the building occupied by the Bachelor in Technical Vocational Teacher Education Department, or BTV-TED. The BTV-TED is the biggest department because it is composed of 4 different specializations, such as drafting technology, garments, fashion and design, food service management, and electrical technology. Part of the building, especially the drafting rooms, is already half a century old or probably older. The 2-story structure in the middle was added sometime in 2011. This is where you will find the faculty room of the department and an activity center in the second floor. Now, this building is where lecture classes are held, but it also houses laboratory areas for the drafting technology and the garments fashion and design. The laboratory rooms of the drafting technology students have drawing or drafting tables where students put to practice their drawing skills. These rooms are also used by drawing classes of the various departments. Similarly, the laboratory rooms of the garments fashion and design are areas for the GFD students to learn sewing, pattern making, garments design, and the like. Behind the TVTED building is another recently completed building, the Bicol Regional Food Innovation and Commercialization Center, which became operational sometime in the middle of 2018. As the name implies, BRFICC is where food products are innovated and later commercialized. This is also currently occupied by classes for the Food Technology Department, the department where students learn everything related to food science, food innovation, and other relevant concepts and applications. Fronting the BT Vital building is the Quadrangle. Then across the campus road from the Quadrangle, one sees another building called the Food Technology Building. This bears this name because in the past, BUSAT used to have 2-year vocational courses and food technology was one of the said courses. Today, however, this building is now being used by the food service management students where they hold their classes in laboratory. In the laboratory, students learn about basic baking, quantity cookery, catering management, and other similar courses. Across the campus street to the right of the FT building is another long building fronting the sunken garden, the Civil Technology Building for the Civil Technology Department. This building also holds the office of the BUROTC Coordinator and the office of the College Publication, the Coverall. In the laboratory rooms of the Civil Technology Department, students learn the basics of civil craftsmanship. Behind the city building is the IA building. This is another building being used by the Food Technology Department for their lecture classes and some laboratory classes as well. Going farther down the road across the campus road from the IA building, behind the FT building, one sees another very old, vacated, and now shabby L-shaped building. This one used to be occupied by the students of GFT and the electrical technology students for their laboratory. Both the GFD building and the city building are now in the pipeline for renovation. Furthermore, a new food science building for the Food Technology Department will also be constructed. Then we proceed to the last but not the least concrete structure of the college, another old L-shaped single-story building, formerly known as IDE building, and now being occupied by the Industrial Design Department. Here, the ID students learn the various types of design, including raw materials important for design and other relevant concepts. Of course, let us not forget the administration building, where you will find the office of the dean, office of the associate dean, office of the registrar, and the cashier's office. This building is actually far from the school buildings of the college because it is situated to the northwest of Boy Maso, in the same building occupied by the Seng Administration Building. Mind you, our dear freshmen, most of the buildings may be old, but these buildings have seen many outstanding students who have sat in the classrooms or walked the corridors or hallways and are now distinguished, highly admired persons in their fields. Today, you see old buildings, but one day, perhaps not yet in your time, the college will also be one proof that the university's vision of a world-class university has been realized.
Takbiuenyo, whoa, oh, whoa, 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 whoa. Mga pangarap kayang abutin, pag-asa ng ambisyon natin, di kukuha at tulog-tulog. Saan man magpuntay, isa ang ulong. Ako, ikaw, tayo, kahit sino pa, pantay-pantay ang tingin sa isa't isa. Isang pangarap susuko. Kahit anong problema, wala lang yan basta tidaan sa ngiti lang. Pasok na yan ang laging isipin na tayo'y tatakliwen nyo.
Ngunit kahit di mabuti ang kinasasabakan mga balakid sa daan parang hindi malagpasan. Tumingala, subituin ang karunungan pag sinabing biyuan nyo hindi yan uurungan. Dugo kasun, ating tinataglay, ilapas mo sa baon, amin kong ibinigay sa tinadya sama. Kumbaga, iba ka sa kanila kung di ka nila mapatuloy niyan. Kanta!
Mga talento natin na iba-iba, sa pamumuno tayo'y nagiging isa. Sa serbisyo, hindi nagsusukuan. Kahit di na kaya, ay kakayanin pa. Tumayong itak, sumayaw tayong biyuhan nyo. Sama-sama tayo, tunay na naganda ang taglay ng ating mga puso. Walang susuko, kahit anong problema, wala lang yan basta tidaas ang ipila. Pasok na yan at laging isipin na tayo'y tatak. Mayong itak, sumayaw tayo ang biyuhan nyo. Sama-sama tayo, tunay na naganda ang taglay ng ating mga puso. Walang susuko, kahit anong problema, wala lang yan basta tidaas ang ngiti lang. Pasok na yan at laging isipin na tayo'y tatakliwen nyo. Wow, oh, tatakliwen nyo. Wow, 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 laging isipin na tayo'y tatakliwen nyo.
Isang kapanapanabik, nagbabaga na umaga sa inyong lahat. Magandang umaga po sa ating mga participants na kasama natin ngayon mula dito sa Zoom. Ganun na din sa mga nakasubaybay sa ating Facebook Live. At sa lahat ng mga datihan, baguhan at kakapasok lang, magandang umaga po. Good morning also to our dear foreign participants that is present with us today. At sana ayos lang po kayo dyan. Kamusta po kayo? Kamusta po ang bawat isa? Sana ay okay kayo dyan. At halos 2 weeks tayong di nagkita-kita. Belated Happy Halloween po pala sa inyong lahat. Marami ang nangyari sa mga nakalipas na araw at lalo na sa pagdating ng Bagyong Paeng. Dahilan kung bakit hindi kailangan natin ipagpaliban yung tech talks natin nung nakaraan na Sabado. At salamat naman, at nalagpasan natin itong pagsubok. At heto tayo ngayon, nagkita-kita muli at nagsama-samang muli para sa panibagong kaalaman na makukuha natin ngayong araw. Okay? Alam nyo, this is the kind of day that we should be grateful for. Kasi ito yung unang araw, itong unang Sabado na pagpasok ng buwan ng Nobyembre at gawin natin itong makabuluhan at punong-puno ng kaalaman na madidiscover natin para sa unang Sabado nitong buwan. Kaya naman as a bonus for that, we will give you an amazing discovery and learning for today's event. And guess what? We are now down to our 7th episode. Yes po, tama po, episode 7 na po tayo. At kung meron na K-drama series, anime, or whichever, meron din po kaming webinar series. At kung merong TikTok, we have Tech Talks. Episode 7, Tech Talks, Teaching Technology Towards a Better Normal. Alright. And as we all know, that our society is totally dependent on electrical and electronic systems. At mahalaga ito sa ating pang-araw-araw na buhay. Mula sa power generation, distribution, communications, manufacturing, saan pa ba? Hospitals, factories, computers, fast food joints, automobiles, even electrical installations, mapa residential, commercial, at marami pa pong iba. Kung wala itong dalawa, panigurado our society would totally collapse. At malalaman natin maya-maya lamang ang application ng electrical at electronics. Kaya pasulyap lamang po yan. Kaya relax po muna tayo dyan. At abangan natin mamaya kung ano pa ang marami nating matututunan. Okay? So, bago ang lahat, this event is in partnership with Electrical and Electronics Technology. And before we begin, gaya ng dati, I have a few housekeeping notes. Everyone is encouraged to keep their cameras open, but make sure our microphones are on mute to avoid unnecessary background noises that can interrupt the program or when someone is speaking. We can also interact with our speaker during our open forum through the chat box if you are on Zoom, and you can have your questions in the comments section if you are watching through our Facebook Live after the talk of our speaker. And I would like also to grab this opportunity to give the gratitude to our diligent President, Dr. Arnulfo Mascareñas, our passionate Vice President for Academic Affairs, Dr. Amelia Dorosan, Vice President for Administration and Finance, Attorney Joseph Bartolata, Vice President for Research and Development and Extension, Dr. Luis Amano, and to our exuberant BU-EMD Director, Rowena Zoilo, our BUSIT administration, headed by our supportive Dean, Dr. Jonathan Arojo, our dynamic Associate Dean, Professor Arlene Valleras, the faculty, and the staff. And also to the presence of our BJMP community, BISET, and BISAUT students, and the students from other universities and colleges, teachers, alumni, electrical and electronics enthusiasts, and everyone. This webinar would fail to happen if it were not because of our beloved organizers. Of course, the technical team, headed by an amazing professor, Ronel Oropesa, also to Mr. Dave Azores for the incredible design, and also to the BUSIT Extension Coordinator, Ma'am Wilma Pahabera, and to our very supportive Department Chair of Electrical and Electronics Department, Professor Joel B. Habalo, and the full support of the BUSIT College Student Council. And of course, why would I forget the proponent and project leader of this webinar for this extension activity, the BISET Program Advisor, is none other than Dr. Kenji Merenciano. Without his idea, of course, this event would be non-existent. At maraming salamat po sa lahat ng bumubuo nito. Kaya bigyan po natin sila ng isang malakas na virtual clap. Alright, thank you everyone. By the way, ako nga po pala ang inyong host ngayong araw, Angel Pai, a BISAUT alumni, at ako ang makakasama nyo ngayong araw ng Sabado. Okay. And now let us proceed to the invocation to be followed by the national anthem.
Tayong magiliw, pelas ng silangan, nananag ng puso, sa dibdib mo'y buhay. Lupang hinirang, duyan ka ng magiting, sa manlulupig, di ka pasisilip. Sa dagat at bundok, sa simoy at sa langit mabaga, ay nilagang tulad, awit sa paglayang minamahal. Ang kislap ng matawat mo'y tagumpay na naglilingig. Ang bituin at araw niya, kailan pang mali magdidili. Lupa ng harangan, bakit pagsinta mo'y langit sa piling mo? Aming ligaya na pamay mga pirang mamatay ng dahil sa'yo.
All right. So good morning once again, our dear participants. Excited na ba ang lahat? To say this frankly, excited na po ako sa panibagong programa ngayong araw. So let's not prolong the agony of waiting to formally open the program for BISET and Bisal Tech Talks webinar series. Let us welcome our very supportive, active professor from BISET faculty, Professor Joel Ensales, to give us the opening remarks. Good morning, sir.
Good morning.
All right.
Welcome to our 7th week of Tech Talks. As our tradition, we would like to acknowledge first our early registrants. We have our mainstayer from Al-Balka Applied University, Salt Jordan, Ahed Al-Fawri. We have Abdullah Sandio, education student, the Mentors Academy, Lakama, Sindh, Pakistan. We have private employees from ATI Technologies, Ontario, Canada. Another private employee from WBM Technology, Calgary, Canada. We have Edward Abaroa, an employee of Kiwi Railway Operations, Wellington, New Zealand. We have Jojo Lositanio, employee of Wells Fargo, Taguig, Metro Manila. We have private employees from UCU Philippines Manufacturing Company, Dasmariñas, Cavite. A government employee from DPWH, Quezon City Engineering Department. Welcome to government employees of DPWH Region 8, Palo Leyte. We have IIEE CSC CSPC chapter, Camiguin Province, our mainstayers. Also, welcome to engineering and technology students from Institute of Creative Computer Technology, Cainta, Rizal. Information and technology students from ICCT College, Baguio City. Education students from University of Cagayan Valley, Tugigaraw. Agricultural students, Pampanga State Agricultural University, Magalang, Pampanga. Also students from Polytechnic University of the Philippines, Santa Mesa, Manila. Faculty and students, National Teachers College, Nepomuceno Street, Quiapo, Manila. We have Joy Kenneth Biasong, a principal from Bauktech Academy by Center, Cebu City, and nursing and medical students from Ago Medical and Educational Center, Albay District, Legazpi City. And also to our new registrants from Zoom, we have BJMP, Kamalig, si Eward Repomanda, si Christian, si Edsel, Santa Rosa, si Edmar Listangco, si Edward, si Ella, Gerald, si Lemuel, and many others who are watching us in Zoom. So welcome everyone Our last topic is about electrical and electronics assembly. It is about how we integrate different components to come up with a particular device. Our topic this morning is another very interesting one, wherein we will learn the different electrical and electronic devices applications. What is the difference between electrical devices against an electronic devices? Electrical devices are being operated by high voltages, while electronics devices are being operated by low voltages, ranging from 12 volts down to 1 volt or less. A direct contact with high voltages, not considering the safety, can result to death. On the other hand, handling low voltages is less harmful to human. Example, our mobile phone battery need only 3 to 5 volts DC to operate. These electronic devices contributed much to the economy of our country. According to the Philippine Statistics Authority, electronic products continued to be the country's top export in August 2022, with a total earnings of 3.66 billion US dollars. This amount accounted for 57.1% of the total export during the period. So as you can see, the importance of electrical and electronics contribution to the economy. So later in this topic, you will hear the term transducer, and at the end, you will be able to define the term transducer. As John Ford said, electronics is clearly the winner of the day. Also, according to Earl Warren, Benjamin Franklin may have discovered electricity, but it is the man who invented the meter who made the money. So indeed, Nikola Tesla, the person who popularized AC voltages, died as financially poor. I hope that you will learn something about our topic for today. Again, thank you and happy learning.
Ayan, thank you so much, Professor Joel, for those wonderful welcoming remarks. Okay? Mukhang marami na naman tayo ngayon, iba't ibang participants mula sa ibang bansa at saan mang sulok ng Pilipinas. Again, welcome po sa mga bagong dating. And I think now it is my pleasure to introduce to all of you for our speaker for today's episode. Our speaker for today is a graduate of Bachelor of Science Electrical Engineering, year 2009, Bicol University College of Engineering here in Buseng, Legazpi City, and he is finishing Master in Engineering in Camarines Sur Polytechnic Colleges, or CSPC, Nabua. His work experience, he works at LRT Line, 1 Pasay City Electrical Engineering Maintenance, also in Rolling Stock Department, Light Maintenance Section, year 2010 to 2014. In Sutherland, Cubao, Quezon City, Facility and a Property Engineer Facility and Property Management Admin and Facility Department, year 2014 to 2018. At present, he is an Instructor 1 at Bicol University College of Industrial Technology, Electrical and Electronics Department. Let us all welcome today's speaker for today's Tech Talks webinar series, episode 7, Electrical and Electronics Application, Professor Edan O. Navera.
Hello, thank you, Angel.
Ayan, good morning po, sir.
Good morning po sa lahat. Welcome sa 7th episode ng ating Tech Talk. For today's video, ang ating i-discuss is regarding electrical and electronic device applications. Wait lang po. Okay, again, good morning. For today's topic, we will discuss regarding electrical and electronic device application. Previously, my colleagues discussed regarding digital circuits, electronics and electrical circuits, circuit design and simulation, and electrical and electronics assembly. Itong topic na to, electrical and electronics device application, parang summary ito ng mga diniscuss nila. Ngayon, i-discuss na natin yung application. So, let's first define electrical and electronic devices. Electricity and electrons are of course interrelated with each other. Electricity is the flow of electrons, and electronic is the technique of controlling the electrons to perform a specific task. Both use electrical energy for the purpose of doing work. Electrical device convert electrical energy into another form of energy like light or sounds. While electronic device controls the flow of electrons performing the task like amplification or calculation. Electrical devices. These devices which convert the current into other forms of energy or works. Such type of device is known to be the electrical devices. It uses metal for conduction. The electrical device mainly works on high alternating current. The power consumption of electrical device is also very high. The electrical device are more dangerous or less reliable because it causes hazardous electrical shock, and the size of the electrical devices is very large. Hence, it requires more space. Example of this device are the fan is the electrical device which convert the electrical current in the form of rotational motions. The electrical bulb is another example. It converts the current into light. The heater converts the current into heat. Now we proceed to electronic devices. Electronic devices, the device which controls the flow of electrons to perform a particular task. Such type of device is known as the electronic devices. The word electronics means the study of the behavior of electrons under the effect of electrical field. The electric components are mainly classified into two types. They are active component and the passive component. The component which delivers energy is known as the active component, and the device which receives energy is known as the passive component. The electronics have three main active components and two main passive components: the resistor, capacitor, and inductors. What are the difference between electrical and electronic device? Number one, the electrical device changes the current into another form of energy like heat, light, and other forms of energy. Wherein the electronic device, it controls the movement of electrons for performing the operation. Number two, the electrical device use copper and aluminum wires for the flow of electrical current, where the electronic device use the semiconductor materials. The electrical device mainly work on alternating current, where the electronic device works on direct current. The electric device work on high voltage, where the electronics device work on low voltage. The power consumption of electrical devices is more as compared to electronic devices. Then, the conductivity of electrical devices is high, where in electronics, it's low. The electrical device do not manipulate data, where the electronic device manipulate the data. The electrical device directly works on the current, due to which it gives quick response. The electrons are the only moving charge of electronic device, hence the response times is less. The electrical device is heavy. The electrical device is heavy and large in size, hence it requires space, and the electronics components is very small, so it needs less space. The another difference is that electrical device is more dangerous compared to the electronic devices. Their similarities: the electrical and electronic device both depend on the flow of electrons for performing an operation. Both the device use the transformer for transmitting the voltage. The electrical device use both instrumental and power transformer, and the electronic device only use the instrumental transformer. Okay, so yun po ang pagkakaiba ng dalawa, electrical and electronic device. Si electrical device, more ginagamit siya sa mga malalakihang industries, while si electronics components sa mga maliliit na bagay po. Ito, punta na tayo sa mga examples ng electrical devices. Some examples of electrical devices includes transformer, light bulbs, motors, generators, vacuums, toasters, and other technologies such as the electric telegraph and batteries. Electrical devices are defined as the device that use or generate electricity and transform it into another form of energy, such as motion, heat, or light, or etc. The transformations created by electrical device are simple in nature and typically serve to do only one action. Electrical devices are in a different category than electronic device. An electronic device, such as a modern cell phone or MP3 player, uses complex manipulation of electricity to perform additional actions by utilizing the electronic current to add audio or visual information. Electrical devices predate the creation of electronic fields of study by approximately 100 years, with the first electrical batteries being invented in the 1800s by Alessandro Volta. Some archaeological evidence has also found that an electrical battery was in use in the ancient Persian Empire in the second century BC. Other early electrical device includes the telegraph, which was invented in 1830s. The telegraphs later used Morse code, which was invented by Samuel Morse to allow for nearly instantaneous communication over long distance. Modern electrical devices often have electronic components in them, such as temperature control feature on a toaster. Now, these are the sample of electrical device and its application. First, we have transformer. Siguro alam nyo naman kung ano yung transformer. Kakita tayo sa mga poste ng mga transformer. Meron din tayo yung mga maliliit na transformer. So, i-discuss natin ngayon yung application po niya. A transformer is an electrical device that uses the principle of electromagnetic induction to transfer energy from one electric circuit to another. It is designed to either increase or decrease AC voltage between the circuits while maintaining the frequency of the current. The first transformer was invented in 1884 in England and it revolutionized the way AC power could be used. The transformer was first used in the first AC power station, the steam-powered in Rome power plant in 1886. Using the transformer, AC power could be generated and supplied at high voltage, and then step down to a safer and usable voltage to use in homes and business. While this original basic design is still used today, modern transformers are used for a wide variety of applications. Those used in electrical power station can be several stories high and are used to transmit power at high voltage, which is more efficient than doing at low voltage. Signal and audio transformer are much smaller and are used to match the output of microphones and other audio devices to input of amplifiers. These are the samples of transformers. Makikita natin to sa mga poste, sa mga substation. Itong isa naman, itong maliliit, makikita natin to sa mga electronic device, sa mga regulators, ABR, sa mga other small devices. Makikita natin ito. Ito naman sa mga malalaking establishment natin sila makikita. There are two types of transformers based on usage. One, the power domain, and the other one is the electronics domain. Under power domain, there is three: power transformer, measurement transformer, and the distribution transformer. While on the electronics domain, we have the pulse transformer, and the audio output transformer. So we go to the power domain. In the power domain, the first one is the power transformer. Power transformer are larger in size and used to transfer the energy to the substation or the public electricity supply. This transformer acts as a bridge between the power generator and the primary distribution grid, depending on the power rating and the specification of the transformer. There are three classifications of this transformer: the small power transformer, medium power transformer, and the large power transformer. The rating can be more than 30 kVA to 500 to 700 kVA, or in some cases, it can be equal to more than 7,000 kVA. Due to very high power generation, the construction of power transformer is also critical. The construction includes solid insulation and well-balanced cooling system. The most common power transformer are filled with oils. The main principle of power transformer is to convert the low voltage, high current to a high voltage, low current. This is required to minimize power loss in the power distribution system. Another important parameter for the power transformer is the phase availability. Typically, power transformer works in three phases, but in some cases, single phase small power transformer are also used. So yung mga ganito pong transformer, kadalasang makikita natin to sa mga power distribution. Kung dito sa Albay, makikita natin to sa mga substation ng APEC or ng ALECO, or kung sa Camsor naman, Casoreco. Ito yung mga makikita nating kung sa Manila naman, sa Meralco substation, ito yung makikita nating mga transformer. Itong transformer na to, isang electrical device, ang use nito is to step up the voltage but lower the current. para pag nag-transmit siya sa power lines, konti lang yung power loss niya. So halimbawa, yung voltage niya 200 volts, pag step up siya, magiging lang kVA. So ito yung mga step up transformer. Ito ang mga malalaking transformer na to. Isa ito sa mga example ng electrical device. So ang application niya is to step up voltage. Next is the measurement transformer. Itong mga measurement transformer na to, kasama to ng mga malalaking power transformer. Ginagamit ito for protection kasi ititrigger niya yung mga na mag-disconnect or ititrigger niya na mag-disconnect pag nakakasend siya ng mga high voltage or may mga fault. Okay. Sa measuring transformer, meron tayong current transformer and potential transformer. Measurement transformer is often referred to as an instrument transformer. This is another commonly used measurement in the power domain. A measurement transformer is used to isolate the main power and convert the current and voltage in a smaller ratio to the secondary output. By measuring the output, the phase current and voltage of the actual power line can be measured. Current transformer and potential transformers are instrument transformer basically used for measurement and protection purpose in power system. A current transformer is used to obtain reduced current signals for purpose of measurement, control, and protection. They reduce the higher current to lower values, which are suitable for operations of relay and other instrument connected to the secondary windings. While a potential transformer, it is used to reduce the voltage to lower values and to provide isolation between high voltage power network and the relays and the other instrument that are connected to their secondary. So pag nakasend siya ng high voltage, ititrigger niya yung relay para mag-disconnect siya sa secondary or sa mga nakakonect pa sa kanya. So yan yung use ng current transformer at potential transformer na isa ding sample ng electrical devices. So we go now to distribution transformer. Ito yung mga usualing transformer na nakikita natin sa mga poste. Ang tawag sa kanya is distribution transformer. This is used in the last phase of the power distribution system. Distribution transformers are step-down transformers which convert high-grid voltage to the end customer required voltage. Siya yung nagko-convert to 110 or 230 volts. It can also be single-phase or three-phase. The distribution transformer can be smaller in shape as well as bigger depending on the conversion capacity rating. Distribution transformer can be further categorized into based on the type of isolation it uses. It can be a dry type or can be liquid immersed. Liquid immersed. It is made using laminated steel plates mostly constructed in C-shape as a core material. Distribution transformer are also has a different type of classification based on location it is used. The transformer can be mounted on utility pole. It is called pole-mounted distribution transformer. It can be placed inside an underground chamber, mounted on a concrete pad, or inside an enclosed box. Generally, distribution transformer having a rating of less than 200 kVA. So how electricity reaches our homes from power plant. Dito na papasok ngayon yung power transformer. i-step up niya. Then, papunta sa transmission line. Then, i-step up ulit pagdating sa transmission line. Then, papunta na sa mga distribution substation. Bakit ini-step up yung voltage? Kasi, sa haba ng tinatravel niya, nagkakaroon ng losses. Nagkakaroon ng power drops. So, kailangan ulit siyang i-step up sa mga substation. So, pagdating sa pole, papunta niya sa bahay, hindi naman pwedeng sobrang laki ng voltahe niya. So, itong mga distribution transformer, siya na ngayon yung mag-step down ng voltage para yung tamang voltage yung magagamit natin sa ating mga household appliances. So, ito po yung sequence kung paano nakakarating sa atin ang electricity. From power plant to step-up transformer to transmission line, transmission substation, distribution substation, sa mga poles natin, service poles na may transformer papunta sa ating mga bahay. Yan po. Ito pa ang mas detalyado. For example, galing dito sa power station, 25 kilovolts. Tapos, i-step up siya. Lagi siyang 400 kilovolts or 275 or 132 kilovolts. Depende sa kailangan. Tapos, pagdating dito, parehas pa rin siya. Tapos, i-step down ulit siya pagdating dito. 132 kV na lang to 33 kV. Pwede na siya sa mga heavy industry, sa mga manufacturing, pwede na siya gamitin. Tapos pagpapunta na sa mga bahay natin, yung 33 kV or 11 kV, i-step down pa siya to 230 volts. So, isa sa mga example ng electrical device is transformer. Ginagawa niya, nag-step up siya ng voltage or nag-step down siya ng voltage. Pwede rin siyang maging protection kagaya ng mga current transformer and potential transformer. Next, meron pa tayong electronics domain na mga transformer. Ito naman yung mga maliliit na transformer. Una, yung pulse transformer. Ito po yung itsura niya. Ito naman po yung diagram niya. In electronics, various small miniature transformer are used, which can be PCB mounted or can be fixed inside a small product. Pulse transformer. Pulse transformer are one of the most used PCB mounted transformer that produce electrical pulse in a constant amplitude. It is used in various digital circuits where pulse generation is needed in an isolated environment. Therefore, the pulse transformer isolated the primary and secondary and distribute primary pulse to the secondary circuit, often digital logic gates or drivers. Itong pulse transformer na to, ginagamit sa mga digital logic gates na previously diniscuss yung mga logic gates ni Engineer Bustamante. The application of pulse transformers includes the following: pulse generating circuits, analog switching application, SCR, power electronics, data handling circuits, radar, switching transistors, communication, microwave tube circuits, control circuits for firing control, cathode ray tube circuits, radar system, digital electronics. The transmission line pulse transformer is mainly used in the application of quick transmission of pulse signal and also in digital signal transmission. The advantage of pulse transformer includes the following: small in size, high isolation value, inexpensive, exterior power supply is not required, It operates at high frequency. It is capable for transmitting high energy, includes more windings, avoids stray current. It gives insulation and control. While the disadvantages of pulse transformer includes the following. At low frequency, both the output waveforms are different from each other. The DC supply throughout primary winding to decrease the saturation of the core. This kind of transformers saturate at fewer frequency. Thus, it can be utilized for only maximum frequency only. The signal is unclear because of the magnetic coupling. Those are some of the disadvantages and advantages of pulse transformer. Next, under electronic domain transformer is the audio output transformer. Ito po yung sample niya. Ito yung kadalasang nakikita natin sa mga project na transformer. Ito yung parts niya. Ito yung application niya. Ginagamit siya sa mga speakers, sa mga amplifiers. Audio output transformer is another commonly used transformer in electronic domains. It is especially used in audio-related application where impedance matching is required. Audio transformer balances the amplifier circuit and the loads, typically a loudspeaker. The audio transformer can have multiple primary and secondary coils The audio transformer can have multiple primary and secondary coils, separated or center tap. Audio frequency transformer works at frequency between about 20 Hz to 20 kHz and are used in audio amplifier circuits. They were essential in bulb designs for matching the high impedance output of these amplifiers to low impedance loudspeaker. But transistor amplifiers have much less need for output transformer. Audio frequency transformer are still produced, however, to range of audio function. Audio transformer often perform several functions at once. Where used, they allow the AC audio signal to reach the loudspeaker, preventing any DC from amplifier affecting the operation of the loudspeaker. They provide an isolated external connection for loudspeaker, improving safety. They can match the low input impedance of the loudspeaker, typically a few ohms, to the much higher output impedance of an amplifier, allowing maximum power to be transferred from an amplifier to the speaker. So, isa po to sa mga examples na isa po ang transformer sa mga example ng electrical device. So, bigay pa tayo ng isang sample ng electrical device is the light bulb. An electrical light lamp, or commonly called light bulb, is an electrical device that produces light. It is the most common form of artificial lighting. Although incandescent light bulbs are cheap, effective, and very easy to use, they aren't very efficient. They generate a lot of heat. More advanced technology, including fluorescent lights, light-emitting diodes, or LED, are much more efficient, generating more lights and less heat. This newer technology uses less energy and are well on their way to replacing the regular light bulbs. So kung makikita natin ngayon, konti na lang yung tinatawag natin na incandescent bulb or yung makikita natin na kulay orange na bulb. Kasi hindi siya masyado efficient, tapos nagki-create pa siya ng heat. Pero nagpo-produce pa din ngayon ng mga incandescent bulb. Ginagamit siya sa mga sa mga medical field for incubation kasi nga mas nagpo-produce siya ng heat. Nagpo-produce nga siya ng ilaw pero more heat din ang napoproduce niya. So ngayon, ang nauuso na ng lighting fixture is the LEDs or meron din tayong fluorescent lights. Ito na yung mga ginagamit ngayon. So ito yung mga sample ng mga light bulbs natin. So ang light bulb is another example of an electrical device. Then another example for electrical device are motors. An electric motor is an electrical device that converts electrical energy to mechanical energy, usually by employing electromagnetic. Most electric motors develop their mechanical torque by interaction of conductors carrying current in a direction at right angle to a magnetic field. The various type of electric motor differs in the way in which the conductors and the fields are arranged and also in the control that can be exercised over mechanical output, torque, speed, and position. Motors have also influenced how we live at home. Ito yung mga sample ng motor. Meron tayong AC motor, meron tayong DC motor. Ito yung mga parts niya. Meron tayong commutator, brush assembly, stator, yung frame, yung shaft, yung armature. Ito naman sa kabila, ito yung difference ng AC motor saka DC motor. Sa DC motor, may carbon brush pa siya, while dito sa AC motor, wala na siyang carbon brush. Motors have also influenced how we live at home, especially when it comes to doing house chores. Here are some surprising examples of household appliances and devices that uses electric motor technology, or at least those you may have not thought of at first. First is the computer. Yes, the computer uses motor. One of the most common household appliances ever since the dawn of internet, computers do in fact sport motors. Even if at first glance it doesn't seem to have any moving parts, the motors have to do with its hard disk. Isang computer, meron tayong hard disk. It spins the plates in the drive and read the data stored on them. The cooling fans that which hot airs moves the hot airs from the inside or on the unit that requires motor to spin. So isa ito sa mga example ng motor sa isang computer. Yung hard drive niya po, may motor din po siya. Ito yung sample niya. Then next, the refrigerator. Another common household appliance, the refrigerator, it needs small motors to operate its compressor. This compress the refrigerant chemical into a liquid form to create the cold temperature that help preserve the fresh goods, and air condition works in similar fashion. So another sample ng motors na makikita sa household is the motor in the refrigerator. Ito po siya. Mga sample po yan ng electrical devices na ginagamit na in application po. Then another one, common washing machine. A washing machine needs a heavy-duty motor to be able to do its job, cleaning your dirty laundry. For twin tub machine that have a washing tub and a spinner tub, 2 motors are needed. The front-loading machine and the other hand generally to make do with one. Sa mga washing machine, may motor din po tayo, pero yung may mga spinner, dalawa po yung motor niya. Meron para doon sa paglalaba, meron para sa pag-dry yung spinner niya. Another example is a vacuum cleaner. This is a reliable device, requires a powerful suction motor to suck in dust and dirt off the floor. Some models even allow for float air to reverse it. This allow you to use your cleaners as a blower in a hurry. So ito naman po, itong vacuum cleaner, may motor din siya. Usually sa vacuum cleaner, pwede siyang yung suction, pwede din siyang blower. Tini-reverse lang yung switch niya sa motor po. Another one is the smartphone. Yes, the pocket size computer in your bag does have a couple of motors inside it. One of them is the one that gives you phone its vibration function. Motor din po yung nagpapavibrate sa kanya, pero maliit lang na motor. There's also one in your phone's camera lens to help it focus, zoom, as well as stabilize the image. Kung makikita nyo yung mga high-tech ngayon na phones, na po pwede siya mag-zoom, pwede siya i-ultra-wide, may motor din po siya na nagdadrive sa kanya. So ang motor po, hindi lang siya pwedeng malaki, pwede din po siyang maliit na maliit. Pero ang function niya, parehas pa din po. It serves an electrical device po. And itong mga dinidiscuss po natin, ito yung application po nila. There you have it, some of the most common household applications and appliances and devices that use motors. Some quite obvious, other not overly so, especially if you have never really had experience in taking them apart. But it really does go to show just how much the advent of electric motors has changed the landscape of modern convenience, and we can only speculate what sort of game changer could come next as technology advances ever onward. Do you have any motor-powered appliances or device in mind? Comment down below. Now we proceed to electronic device application samples. One of example is the transducer. Transducer is an electronic device that converts energy from one form to another. Common examples includes microphones, loudspeakers, thermometers, position and pressure sensors, and antenna. The transducer is classified as the active and passive transducer. Transducer is classified as an active and passive transducer. Passive transducer, the transducer which requires the power from an external supply sources, is known as the passive. They are also known as the external power transducer. Understanding what a transducer, consider the following setup of a measuring system. In this block diagram of simple measuring system, there are three basic elements: the sensor, signal conditioning unit, data representing the device. These are the three basic elements: the sensor, the signal conditioning unit, and the data representation. Magsimula dito sa sensor hanggang dito sa signal conditioning unit, ito yung transducer natin. A sensor is a device that used to detect changes in any physical quantity like temperature, speed, flow, level, pressures, etc. Any changes in the input quantity will be detected by a sensor and reflected as changes in output quantity. Both the input and output quantities of a sensor are physical, sample, non-electrical in nature. Then we go to the signal conditioning unit. The non-electrical output quantity of the sensor makes it inconvenient to further process it. Hence, the signal conditioning unit is used to convert the physical output of the sensor to an electrical quantity. Some of the best-known signal conditioning units are analog to digital converters, amplifiers, filters, rectifiers, and modulators. Then we go to the data representation device. A data representation device is used to present the measured output to the observer. This can be a scale, an LCD display, or a signal recorder. In the above example, consider a strain gauge as the sensor. Any changes in the strain will reflect as changes in the resistance. Now, in order to convert these changes in resistance into equivalent voltage, you can use a simple Wheatstone bridge circuit which acts as a signal conditioning unit. The combination of the strain gauge, the sensor, and the Wheatstone bridge, the signal conditioning unit, is known as the transducer. Itong dalawa na to, nagpapaloob sa dalawa na to, ito ang tinatawag na transducer. Generally speaking, a transducer is a device that converts one form of energy into another by principle of transduction. Usually, a signal is one form of energy is converted to a signal in another form by a transducer. Then we go to the sensors and actuators. Both sensors, device that responds to physical quantity with a signal, and an actuator device that responds to signal with a physical movement can be considered as a transducer. For example, a microphone is a sensor which converts sounds into electrical signals, and a loudspeaker is an actuator which convert electrical signals into audio signals. Ito po yung block diagram niya. Yung input po, pumasok dito sa microphone. Then yung system niya, itong amplifier, output device niya, dito sa speaker. So maririnig na ngayon siya dito. Nag-input ka ng sound, dito maririnig sa speaker. Both microphone and loudspeakers are transducer in the sense that the microphone converts sound energy into electrical energy, and loudspeaker converts electrical energy into sound energy. So, one of the examples natin ng electronic device is the transducer. Then, we proceed to another electronic device. Another sample is the resistor. Ang resistor, pwede siya sa electrical, pwede rin siya din sa electronics. A resistor is a passive two-terminal electronic and electrical device that resists the flow of electrons. It is probably the simplest element in electronic circuit. It is also one of the most common components, as resistance is an inherent element or nearly all electronic circuits. They are usually color-coded. The main purpose of resistor is to reduce the current flow and to lower the voltage in any particular portion of the circuit. It is made of copper wires which are colored around a ceramic rod, and the outer part of the resistor is coated with insulating paint. Symbols of resistor. Ito po yung mga symbol, different symbol ng resistors. Ito po yung old IEE symbols. Ganito po yung symbol niya. Ito po yung resistor, trimmer, potentiometer, thermistor, resostat. Tapos po, ito ngayon yung new symbol niya. Ito yung new symbol na ginagamit ng IEE. Ito na po ngayon yung resistor. Ito yung new symbol niya. Sa trimmer naman po, ito yung new symbol nila. Potentiometer, thermistor, resistor, photoresistor. Ito po yung symbols nila. Then we proceed to types of resistors. Resistors are available in different shape and sizes. Common types that are available are through hole and surface mount. A resistor might be static, standard resistor, special, or pack of variable resistor. Ito po yung mga types ng resistor. Meron tayong linear resistor, non-linear resistor. Under non-linear, meron tayong thermistor, photoresistor or LDR, varistor resistor. Tapos under naman sa linear, meron tayong fixed resistor, meron tayong variable resistor. Under variable resistor, meron tayong potentiometer, resostat, and trimmer resistor. Under fixed resistor, meron tayong carbon composition, meron tayong wire wound, meron tayong thick film resistor, meron tayong thin film resistor. Under siya sa fixed resistor. There are two basic types of resistor as follows: the linear and the non-linear resistor. Linear resistor whose value changes with the change in applied temperature and value are known as a linear resistor. There are two types of linear resistor: the fixed resistor and the variable resistor. Fixed resistor. These resistors have a specific value and this value cannot be changed. Following are the different types of fixed resistor: the carbon composition, wire wood resistor, thin film resistor, and thick film resistor. These resistors are fixed. The value cannot be changed. The variable resistor, these resistors do not have a specific value, and the value can be changed with the help of dial or knob or a screw. These resistors find application in radio receivers for controlling volume and tone. Following are example of variable resistors: the potentiometer, resostat, and trimmers. Then, the second type is the nonlinear resistors. The resistor value changes according to the temperature and voltage applied and is not dependent on the Ohm's law. Following are some sample of nonlinear resistors: thermistors, varistors, and photoresistors. Sa resistors, meron tayong tinatawag na color coding ng resistor. So, majority siguro alam naman itong color coding ng resistor na to. Pero for the sake of ng mga estudyante, i-discuss pa rin po natin. So, meron tayong iba-ibang resistor. May iba-iba silang band. Pwedeng may 3 band, may 4 bands, may 5 band, may 6 bands. Kada band, ito yung tinatawag na bands. Ito. Iba-iba yung kulay po niya. Yung kulay niya nakadepende sa chart na to. Halimbawa, yung black, ang value niya is 0. Yung brown, 1. Yung red, 2. Yung orange 3, yung yellow 4, yung green 5, yung blue 6, yung violet 7, yung gray 8, yung white 9. Nalagay ito sa mga first, second, third band for 6 and 5 band. Para naman sa 4 bands, first 2 siya linalagay, yung significant value niya. Tapos, ito yung multiplier niya. Then, tolerance. Gawa tayo ng sample. Halimbawa, itong 6 band. 6 band. Ang unang band niya is color orange. So, 3. Second band niya is red. 2. Third band niya is brown. Brown is 1. Then fourth color niya is red. So pag red, multiply siya by 100. Red ba to? O red. So, yung multiply ngayon siya sa 100. So, naging siyang 3.21 kilo ohm. Itong panglima niyang band, ito yung tolerance niya. Anong kulay ito? Red. Hindi, brown. Ang tolerance niya is 1%. So, the example naman dito sa 5 bands, ang first 3 bands niya, kukunin natin yung value. Halimbawa, itong green, 5. Itong 2, red. Then brown, 1. 521. Multiplier niya black, times 1 lang. So, 521. Multiplier niya is black, times 1. 521. Tapos, yung tolerance niya is 1%. Then proceed naman tayo sa 4 bands. Sa 4 bands, yung unang dalawa lang naman ang kukunan ng value. Yung pangatlo, multiplier. Pang-apat, tolerance. So gray. Gray is 8. Red is 2. Then orange is 1,000. 82 times 1,000, kaya 82 kilo ohm siya. Tapos ito yung tolerance niya, gold. Tolerance niya gold, 5%. So within sa multiply mo tong 82 kilo ohms times 5%, yung nasa gitna niya minus 5% plus 5%, okay pa yung resistor niya. Pero pag bumaba doon sa 5% na yon, hindi na good ang resistor niya. Sample tayo. 82 times 0.5. Wait lang. 82,000 times 5%. Pag ang value ng resistor is nasa 77 hanggang 86, pasok pa siya sa value niya kasi itong 82 may 5% siya na tolerance. Then resistor find their application in almost every electrical component that we encounter in our everyday life. They allow only limited or to the desired amount of current to pass through the electrical devices. Hence, they ensure the proper functioning of the device. Here are some examples of resistors in real life. 1. Street lighting. The street lights get automatically switched on the evening and switch off in the sunlight. This is because they sense the brightness and the darkness due to the presence of the photoresistors in them. The resistance of photoresistor changes with the change in the intensity of light. By using these, circuits of the street lights are designed, and they automatically switch on and off during night and day respectively. The position of photoresistor is adjusted in such a way that factors other than the sunlight, say car headlight or bird shadow, do not affect the working of the street lights. Photoresistors are also find their application in burglar alarms and photographic devices. So isang application na naman ng resistor is a street light. Kasi makikita natin ngayon, yung mga solar, di ba, mga street lights natin ngayon, naka-solar na siya. Wala namang mag-switch on, switch off sa kanya, pero meron siyang photoresistor or may photosensor siya. Na pag maliwanag, mamamatay na yung ilaw. Pero pag gumabi na o dumilim, aandar naman yung ilaw. Isa ito sa mga example na ginagamitan ng resistor, the photoresistor. Second is the laptop and mobile chargers. Laptops and mobile chargers contain many resistors in them, as they control the flow of current and dissipate heat. Various current readings like 1 ampere, 2 amperes, 500 milliamperes, 7 milliamperes, etc. are inscribed on every charger. This reading represents the amount of current that a particular charger can allow to pass through the mobile or laptop and the speed of charging in the charging device. So, sa mga laptop, sa mga mobile charger, meron naman doon yung resistor na nagko-control sa ampere. Then we have the temperature control. The temperature or heat in the circuit can be varied by changing the resistance in the circuit. This can be understood by the Joule's law of heating. Joule's law states that the heat in the circuit is directly proportional to the square of the current. So meron din po resistor dyan sa mga temperature control natin. Then another sample is the fan speed controller. We can change the speed of the ceiling fans or an electric fans by rotating the knob present on the circuit board. This knob is attached to a variable resistor called a potentiometer. When we rotate the knob, the resistant value change that results in a change in electric current. Hence, the speed of the fan can be controlled by using the potentiometer. So, nagamit na naman natin yung isang type ng resistor na tinatawag nating potentiometer. Na-adjust niya yung speed ng electric fan. Another sample of using an application of resistor is the heating appliance and lighting appliances. Heating appliances like heaters, kettles, toasters, and electric ovens use resistors in them. Resistors turn the electric current into heat and slowly dissipate this heat to make the appliance warm. The filament in the light bulb used in this heat appliance also behave as a resistor, as it reduces the current and heat up the filament wire until it glows. The heat dissipated by the resistor is measured in terms of heating power or watts. Okay. Then another example, an application of electronic device resistor is the LED and transistor protection. Transistors and LEDs are very sensitive to electric current. The overflow of electric current can disrupt the sensitive components of these devices. And very little current in the circuit can affect their proper functioning. A resistor of fixed value is connected in series with the LEDs as they allow only defined value of current range to pass through these devices. Resistors that are used in LEDs are often known as ballast resistors. Ballast resistors minimize the current flow in LEDs and protect them from getting burned. The resistance of the ballast resistor is calculated by expression derived using the Kirchhoff's law and the Ohm's law. Excuse me. Ito po yung diagram niya. Nakaseries po yung resistor natin sa LED. Kasi pag hindi po tayo naglagay ng resistor, pwedeng masira itong LED natin. Depende din sa value ng LED po. Then, next application of resistor is the blower motor resistor. A blower motor is used to run a fan that maintains the air ventilation system of the cars. The blower resistor is connected in series to the blower fan so that the current passing through the blower motor can be controlled by changing the resistance of the blower motor. Blower resistor consists of several resistors, which are used to control the speed of the fan. As when we change the resistance, the current passing through the motor reduces, which lowers the fan speed. Various designs are used for the construction of blower resistor that involve different size wire wound resistors are placed in series for controlling each fan speed, and other design integrated circuit are mounted on the PCB. Ito po yung sample ng blower resistor. Next application of resistor is the filter circuits. Resistors are used in filtering circuits of cell phones and computers that help in damping out unwanted electrical signals. Passive components like a capacitor, inductor are used along with resistor in these filter circuits. The filter circuit acts as a low or high pass filter, depending upon the position of the resistor in the circuit. These circuits block unwanted frequency range and only allows the desired frequency range to pass through the electric circuit. Below is the sample of passive high pass filter. So yung signal niya, may capacitor tayo, then may resistor. Ang makakadaan lang is the high frequency lang. Next, another application is the fusible resistor. The fusible resistor is actually a wire wound resistor. It works as a normal resistor that limits the electrical current at the given power supply. But if the power supply exceeds the normal value, then it acts like a fuse and it gets burned. And it's turned into an open circuit, protecting the devices from the short circuit. So fusible resistor can be used to perform a dual function. First, as a fuse. Second, as a normal resistor in the electric circuit. So those are samples of electronic device application. So application of both electrical and electronic device. Our daily life, if we look around ourselves, we can find a whole lot of electrical and electronics application, such as fan regulator, light dimmer, air conditioning, induction cooking, emergency light, personal computers, vacuum cleaners, UPS, batteries, and chargers. We can find the application of electrical and electronic device in aerospace industry. Today, with the advancement in electronics engineering application in the field of aerospace has opened many impossible ways to humans. Most of the parts used in the space shuttle, satellite power supplies, aircraft power management, and other communication instruments are electronic devices. Even in commercial airlines, there are numerous electronic devices which are used to measure different physical parameters like humidity, temperature, pressure, elevation. Also, application of electronics and electrical devices can be found in militaries. Electronic devices and machineries are also widely used in the military, such as an UAV or unmanned vehicles, drone, which are used in the military for aerial attacks as well as for monitoring. Magnetic anomaly detector, people sniper, night vision device, infrared detector, radar, night vision camera are some gadgets used by the military. And also electrical and electronic device application in medical. With the advancement of electronic fields and particularly the computer technology has made possible many of the applications which made possible for nurses and doctors to examine their patients. Many machines like NMR, ECE, X-ray use electronics. There is noticeable advancement of electronics in the field of medical science. There are a few mind-blowing innovations which prove how important is electronics. Robotic arm, robotic checkup, bionic eye, needle-free diabetic cares, and other things related to medical. Then, another application of electrical and electronics is in automobile. Electronics are used in road vehicles such as lighting system of the car, telematics in a car, sound system. Initially, electronics were used in cars to control engines. Nowadays, almost everything's around controlled using electronics, whether it's a chair in a car or speed limitation in car, gas management in a car. Now electronics with its advancement, it is used in the following parts of the car: the transmission, engine, chassis, passenger comfort, active safety driver assistant, entertainment system. Another application is in the utility system. Electronics has also application in utility systems such as high voltage DC transmission, static circuit breaker, excuse me, excitation system fans, boiler feed, pumps, solar, wind power management system, smart grid system. These are some applications of electrical and electronics in utility system. Also in commercial, electronic device, gadgets are widely used for commercial purpose such as telephone, air conditioning, heating, digital advertisement, power supplies, personal computers, MP3s, office equipment, light dimmer, UPS, and other things. Excuse me. Also in agriculture, electronics has proved to be the biggest problem solver in the agriculture field. Today, number of electronic devices and sensors are used to monitor a crop or enhance the production of agriculture, like e-agri sensors and the other electronic gadgets which are used for measuring the salinity of soil, moisture level, and nutrition level in the soil. Application in communication. In order to communicate for far distance, electronic devices and systems are used as AM radio, FM radio, television, processing, memory storage, display, analysis, protection, etc. Electronic sensors and devices are used to allow friendly forces to operate in virtual environment. It is very useful. We can play games. Also, an application in industrial. Electronics applications are widely utilized in art and industrial furnace such as a blower, fans, pumps, compressor, industrial laser, transformer tap changer, rolling mills, textile mills, excavators, cement mills, weldings, etc. Nowadays, most of the firms use robotics technology such as in the manufacturing of cars. And also lastly, electrical and electronics application in the residential. Electronics device which make our life easy and better, such as air conditioner, cooking appliance, dryer, personal computer, mobile phones, smartphones, and everyday appliances that we use. Okay. Now, I will share my personal experience on the application of electrical and electronics device when I'm still in the field. Because before I went to the academy, I was working at LRT Line 1 as an electrical engineering maintenance, and in Sutherland as a facility and property management. In LRT Line 1 in Pasay, these are some of the application of electrical and electronic device. Sa LRT Line 1, ang nagpapatakbo ng mga tren natin is 750 volts DC. Ayan ang power na nagpapatakbo ng mga tren natin. So, papasok ngayon doon yung transformer. From 220, i-convert muna sa DC. Then, pag DC na siya, i-step up naman siya na maging 750 DC volts. Kasi ang nagpapatakbo ng railways, especially sa LRT Line 1, is 750 volts DC. Tapos, yung mga component na nagpapatakbo sa tren, DC din po siya. Meron tayong 12 volts DC, 24 volts DC, 110 volts DC, 440 volts AC. So, sa isang train set, babalik muna tayo dito. Sa LRT Line 1, meron tayong tatlong klaseng tren. Ngayon pala 4 na. Ito yung pinakaluma. Ito yung first generation o tinatawag nilang BN na tren. BN kasi galing siya sa Belgium. Tapos, ang isang train set, compose siya ng 3 bagon o tinatawag na 3 cars. Tapos, ito naman, ito yung second generation train or tinatawag natin na ADTRANS. 2 na lang ang tumatakbo nito sa ngayon. Ito naman, yung third generation train or tinatawag na 3G. Yung latest ngayon, meron sila yung 4G, yung kakadeliver lang na train, yun yung 4G. Dito as a electrical engineering maintenance, ang mini-maintain namin dito yung buong tren. Sa buong tren na to, since DC siya, yung mga motor niya may carbon brush pa. So yun yung mini-maintain namin. Sa isang car, sa isang tren, merong 2 traction motor. Yun yung nagpapatakbo ng tren. So, traction motor, yung motor is another example of electrical devices. So, paano gumagana yung motor? Kailangan muna siya magkaroon ng supply. So, para magkaroon siya ng supply, kailangan itong parang sungay na to or tinatawag na pantograph, kailangan dumikit dun sa wire sa taas. Yung wire sa taas, yun yung may 750 volts DC, yun yung tinatawag na catenary. Siya yung magsusupply ng power dito sa mga motor natin. Pero paano aangat itong pantograph para makakuha ng supply sa 750 volts? Kailangan siya i-power ngayon ng battery. Itong battery na to, siya yung magsusupply ng power dito sa motor ng pantograph na to para umangat. Pag umangat na to, magkakaroon na siya ng supply, siya na ang magpa-power sa motor ng tren. So, may application pa din yung motor, electrical device, batteries, electrical device. Tapos, meron din siyang mga electronic component. May mga capacitor, resistors. Yan. Isa sa mga application ng electrical electronics na na-experience ko first hand is yung sa railway system natin dito sa Pilipinas. Electrical and electronic device made people lives easier, smoother, and more varied, and reduced distance between nations, such as the use of mobile phones and personal computers. It facilitates communication between individual communities and countries, deepen dialogue, and approach languages, many of which relied on translation features. Electrical and electronic devices are part of our everyday life. Thank you and good morning.
Ayun. Grabe, maraming salamat po, Professor Edan, for the amazing and sobrang daming information na nag-gain namin mula po sa inyo. At alam ko ay marami ang natuto at ngayon, aware na tayo kung ano nga ba yung mga iba't ibang electrical and electronics devices. And these devices and its applications ay ginagamit natin in our day-to-day life. And makikita natin, it is used for lighting rooms, working fans, and domestic appliances like using in electric stoves, dealing with motors, at marami pang iba. And all this provide comfort to people. Sabi nga sa last message ni Sir, na it helps electrical and electronics devices, helps our lives become easier. And we know for a fact that technologies are growing at a very fast rate in the world. Habang tumatagal, mas dumarami ang mga umuusbong na mga devices and mga new practices and applications in different industries at sa pang-araw-araw na buhay. And it is important for technology enthusiasts, gaya natin, na to pace up with the latest changes in our society. Again, maraming salamat po, Professor Edan, para sa ating isang makabuluhan na talk. At alam ko, siguro may mga nakaabang na mga katanungan kayo. Questions in mind, clarifications, reactions. That's good because we will give you the opportunity to speak up and ask questions to our speaker later on. All right. And if you are on Zoom, you can raise your hand. And if sa mga nanonood sa Facebook Live, you can turn your pwede rin po kayo mag-comment below para maitanong natin sa ating speaker. At habang ginagather pa natin ang ating mga thoughts and questions, mayroon kaming inihandang performance para mabuhayan naman ang ating mga dugo at ang ating mga puso at mga isipan. Okay? Huwag na nating patagalin. She is a BTVT Ed Garments Fashion and Design second-year student. She is an active member of Bigao National High School Voice Choral, which led to an exemplary performance on local and international competitions. She is a first place in 2017 Busan Choral Festival and Competition Busan, South Korea. Opo, performance a gala concert during the 2019 Busan Choral Festival and Competition. Same pa rin po sa South Korea, and she is champion in habaneras and polyphony category in 65th Certamen Internacional de Habaneras y Polifonia 2019 in Torrevieja, Spain. Wow. Performed a Europe tour concert around Barcelona, Valencia, Madrid, and Paris, France in 2019, and she'll be singing a cover song entitled Oceans Where Feet May Fail by Hillsong United. Let's have Miss Francine Jane Vertigon. Okay, we're having some technical issues at bago po yan, I remind ko lamang po yung mga hindi pa po nakapag-register sa ating event. Please do the registration form to receive your e-certificates. At sa end po nito, kailangan masagutan po natin yung evaluation. Ano po? Tapos, ayan, shoutout po muna tayo. Shoutout po sa lahat ng mga nanonood sa iba't ibang platforms, sa iba't ibang page sa Facebook Live, mga students, mga alumni, mga teachers, and kung sino pa man po ang mga nanonood. Hello po, welcome po sa aming Tech Talks, and also dito po sa Zoom. Welcome po. Sana okay pa kayo diyan, Tapos kanina lang po natin si JO2 Jenny C. Bobis and JO1 Willie Boy G. Moyo from Kamalig District J. Hello po, maraming salamat po. Ayan. At mamaya shoutout po natin lahat. Ayan, ang ready na? Let's go.
You call me out upon the waters, the great unknown, where feet may fail, and there I find you in the mystery, an ocean's deep, my faith will stand, and I call upon your name and keep my eyes above the waves. When oceans rise, my soul will rest in your embrace. For I am yours, and you are mine. Let me walk upon the waters wherever you would call me. Take me deeper than my feet could ever wander, and my faith will be made stronger in the presence of my Savior. Spirit, lead me where my trust is without borders. Let me walk upon the waters wherever you would call me. Take me deeper than my feet could ever wander, and my faith will be made stronger in the presence of my Savior. Spirit, lead me where my trust is without borders. Let me walk upon the waters wherever you would call me. Take me deeper than my feet could ever wander, and my faith will be made stronger in the presence of my Savior. I will call upon your name. Keep my eyes above the waves. My soul will rest in your embrace. I am yours, and you are mine.
Ayun, grabe. Hindi lang pang Pilipinas, pang international talagang performance. Ano? What a lovely performance we have, and this somehow brings me peace. At for sure, sa lahat din, maraming salamat po, Miss Perdigon, for that wonderful and talaga namang makataas palahibong performance. All right. And now I think we can move on to the open forum as part of this program this morning. Okay. Again, if you have any questions in mind, concerns for our resources, please don't hesitate. Raise it here on Zoom. At sa mga nanonood sa Facebook Live, you can raise your questions in the comment section. I will then read the questions out loud for the resource speaker to answer as time permits. And you can also use the raise hand below and wait to be recognized. And when recognized, please state your name, then your question. Okay? Okay tayo. Uy, ayun. Sir Dan. Maganda pa po ba? Sir, we have some questions galing sa personal message para sa ating galing po kay Tito ng Daraga, Legazpi. Sabi niya po, Sir, ang solar panel po ba ay isang electrical device? At kung opo, can I install po ba solar panels myself po?
Yes, Angel. Thank you sa question. Yes, Tito, ang solar is an example of an electrical device. So, yes, pwede ka mag-install ng mga DIY na solar, yung mga nabibili ngayon, may mga nabibili ngayon na solar na pwede mo siyang isarili install. Pero mas maganda pa rin yung may background ka or napag-aralan mo yung regarding sa solar. Especially mga next episode natin, yung dalawang susunod na episode natin is regarding solar sa introduction sa pag-setup ng solar, tapos yung sa computation regarding kung nakakatipid nga ba talaga sa paggamit ng solar. Sa mga susunod na episode natin, episode 8 and 9, ang i-discuss natin is regarding solar, na isa ding electrical device.
Okay. I hope that answers ano po. Sir, pa-follow up lang daw po. Sinasabi mo po, sir, kanina, kung may balak po kasi siya, sir, na mag-build ng sariling solar system. Makakatipid po ba kaya ako kung gagamit ako ng solar panels instead of sa yung electricity na ginagamit po natin ngayon?
Madidiscuss yan sa mga susunod nating episode. Pero sa paggamit ng solar, makakatipid ka pero in the long run. Kasi on the first few years mo, kailangan mo mag-invest sa mga solar panels, sa mga batteries. Kasi bago mo totally ma-return of investment talaga, kung merong ma-return of investment ang paggamit ng solar. So kailangan mo talagang mag-invest sa solar kung talagang gusto mo mag-invest sa solar. Pero yung assurance kung makakatipid ba or ba sa'yo, long run, mahabang proseso, hindi mo naman kaagad yun mararamdaman. Sa mga susunod na episode, i-explain yan, may computation, merong detailed computation regarding that.
Ayun, siguro sa tingin natin, talaga namang mas effective siguro ang solar panels, pero kumbaga bilang backup na lang po natin since lalo na ngayon mataas ang singil sa kuryente, tapos samahan pa ng madalas na biglaang brownouts, pwede natin siyang maging reserba lalo sa mga emergency or mga kalamidad, pwede po ang solar panels. Although sabi nga po ni Sir Idan kanina, costly po siya pero in the long run maganda po siyang investment. And mas mapag-uusapan pa po natin ito sa ating susunod na mga episode. Tunghayan po natin. Ayan. So meron pa po bang mga katanungan, questions mula po dito sa Zoom? Check natin. Alright. Okay. Okay, since this is, I think, the last questions. Sir, I think we can entertain for today. Sir, question lang po. Sir, isa po akong electrician pero by experience and practice po. Gusto ko po sana mag-aral pero yung hindi po sana katagalan. Ano po pwede para sa akin?
Okay. Kung sa may experience naman siya, meron naman tayong mga short-term course sa pagiging electrician. Meron tayo sa TESDA or meron ding mga private institution nag-offer ng short terms regarding electrical, electronics, or electrical installation and maintenance. Meron tayong mga available na paaralan para sa mga short-term course na yan. Tapos kung gusto naman may mga libre, may mga program din yung government natin regarding sa short-term course sa TESDA. May mga related sa electrical and electronics.
Ayun, so meron mo naman po so yung siguro yung iba na hindi nakapagtapos ng na pag-aaral or wala nang pwede po tayong mag-aral at mag-avail ng mga programa galing po sa gobyerno. One of the examples sabi ni Sir is yung TESDA. Sa electrical po, merong ino-offer na sa mga accredited centers ng electrical installation and maintenance courses. At pagdating naman po sa mga electronics, mga enthusiasts po, meron din po ino-offer ang TESDA ng Electronic Products Assembly and Servicing NC2. Okay? Makakatanggap po kayo ng, I think, meron pong allowance, Tapos meron din po na NC2, tinatawag, kung maipasa po natin yung assessment. Ayun. I hope that answer po, Again, thank you po sa lahat ng nagtatanong. Okay, again. I think kung meron pa po ang pahabol, kung wala na, okay na po. Okay? I think, thank you sa mga participants for giving your time and support for this extension activity. And reminder po sa ating mga hindi pa nakapag-register sa registration link, mag-register na po tayo to have your e-certificate after this. And to receive your e-certificate, click the link on the pinned comment on Facebook and on Zoom and check your email after you are done of the evaluation. Okay? And I think we are already in the last part of our program. So I would like to have this opportunity to have these closing remarks Allow me to give thanks to our speaker for today, Professor Edan O. Navera. Maraming salamat po for the 7th episode, Tech Talks of our webinar series, and giving us enough and additional knowledge of the program BSET and BSET. Okay? So before we close this program, we would like to express our gratitude to the support and approval of the Bicol University Administration, headed by our admirable SUC President, Dr. Arnulfo M. Mascareñas, our passionate Vice President for Academic Affairs, Dr. Emilia De Rosan, Vice President for Administration and Finance, Attorney Joseph Bartolata, Vice President for Research and Development and Extension, Dr. Luis Amano, and to our BUEMD Director, Ruben Zollo, our BUSIT Administration, headed by our supportive dean, Dr. Jonathan Arauco, our dynamic associate dean, Professor Erlene Balleras, to the faculty and to the staff, and also to the designs and layout of the Tech Talks, and to our very supportive professor of BSET faculty, Professor Joel Sales, to the BUSIT Extension Coordinator, Ma'am Wilma Pahavera, and to our very supportive Department Chair of Electrical and Electronics Department, Professor Joel B. Habalo, and to the full support of the BUSIT College Student Council. Maraming salamat po. At syempre, walang iba, the proponent and project leader of this webinar for this extension activity, the BSET Program Advisor, is none other than Dr. Kenji Merenciano. Without his idea, of course, this event would be non-existent. And as a matter of fact, birthday po ngayon ni Sir Kenji, and he is with us today. Happy birthday po, Sir Kenji. Okay? Again, sa lahat po ng bumubuo nito, maraming salamat po. Without your approval and support, this webinar would fail to happen. Maraming salamat po sa taus-pusong suporta sa ating webinar series, and of course, salamat sa Bicol University faculty. At syempre, maraming salamat din po sa ating mga participants mula sa Zoom meeting and Facebook Live. The students of Bicol University, the students outside the Bicol University, alumni, participants from other schools, and our participants from Bureau of Jail and Management Penology from Ginubatan and Kamalig Municipal Jail. Hello po. Kumusta po kayo dyan? Pagpalain po kayong lahat. Again, thank you so much for participating in this webinar series, 7th episode, and we are looking forward to seeing everybody on the next webinar episodes. Okay? And now I think for the catch our episode of Tech Talks. We will be having our assistant professor, Dr. Gilmore T. Alfindo, and Engineer Gilbert Novellero as the resource speakers. The topic they will be discussing is all about cost-benefit analysis. Paganda ng paganda ang bawat episodes every week. Live pa din po kami sa Facebook and also dito po sa Zoom. Pakimark na po sa inyong calendar, November 12, 2022. Same day, same time, 9 to 12 noon. And I hope you have gained new knowledge again today. We'll be seeing you next week, guys. At okay, before po tayo may I request everyone to open your camera po to have our photo op. Picture po muna tayo para meron tayong remembrance para sa ating pagsasama ngayong araw ng Sabado. Okay? Yan. Hintayin natin mga nagkagwapuhan, nagpopogian ng mga participants. Ako na po ang mag-picture. Ayan. Pwede na po ba? Bigyan natin mga 5 seconds to open their cameras. 1, 2, 3, 4, 5. All right. Okay. Okay. 1, 2, 3. Smile. Ayun. Siya pa. Wakin naman.
Nice, Mr. Baroa.
1, 2, 3. Smile. All right. Okay. Maraming salamat po. Ito, ilagay natin sa Okay. Again, maraming salamat po. And now, let's move on to for singing the Bicol University hymn.
This is the school we wish to sing, of a school to honor and revere, a temple built by man of firmness, a mold for you to walk with pride, for he will always be united, although we tread on distant lands. We all shall cherish what you've taught us, that you wholeheartedly gave forth. Bicol University, burning torch of wisdom, fount of courage, hope and love, seed of truth and light. Bicol University, burning torch of wisdom, fount of courage, hope and love, seed of truth and light.
All right, I think that was a wrap. Again, maraming salamat po sa lahat ng mga nagsubaybay at nakasama natin ngayong araw. At sa mga susunod po, magkita-kita po muli tayong lahat. Maraming salamat po. Sana po masarap ang inyong mga ulam at makakain kayo ng marami. Ingat po sa maghapon and have a fruitful Saturday. Bye-bye po.
Zombie Apocalypse.